आज हम थोड़ी सी चार्ज के एग्जिस्टेंस के बारे में बात करेंगे कि हमारी जो चार्ज होती है वो एक्चुअली एग्जिस्ट किस प्रकार से करती है. ठीक है. नाउ मैं आपको बेसिक कंसेप्ट्स आपको बता दूंगा. यू रेफर टू माय वेबसाइट. दिस इज माय वेबसाइट एंड इन दिस वेबसाइट यू गो टू दिस नोट सेक्शन. राइट, वंस यू गो टू दिस नोट सेक्शन यू विल फाइंड माय नोट्स ओवर देयर एब्सोल्युटली फ्री. डाउनलोड कर लीजिए इसको. यू विल फाइंड लॉट ऑफ न्यूमेरिकल, लॉट ऑफ कंसेप्चुअल numericals for the JEE, for the NEET as well as for the board exams. Okay, and as far as today's session is concerned, let us discuss how these charges exist. Right, so अगर मैं इसकी बात करता हूँ तो मैं एक चीज़ बताना चाहता हूँ कि whenever you talk of a charge, right, so whenever you talk of a charge, you might always think they always exist in a form of a point charge, but actually it is not so, right? So charges may exist in number of forms. Now let us see those. Now you will find these charges to exist in basically 4 forms, right? हम 4 फॉर्म की तरह यहाँ पे एनालिसिस करेंगे. Number 1, which we did earlier regarding this Coulomb's law, and that is what is called your point charge, and that is what is called a point charge. Then charges may exist in the form of a line, so that is line charge, and charges may also exist in the form of in the surface basically, and therefore you will have it in the surface charge, or you may also have it in the form of a volume, and that is volume charge. So charges exist in 4 basic forms, right? And these are the 4 forms, right? You can see it over here. और इन्हीं 4 फॉर्म्स के साथ हम देखेंगे कि कैसे कैसे हम इसको क्या बोलते हैं, राइट? नाउ whenever you talk of this क्या कहते हैं आपके point charge. Now when you talk of a point charge, now you will only consider there is a point, and in that particular point there is a charge which is Q. This is the concept we used in our coulombs, right? coulombs में हमने इसी चीज को यूज किया था. In case of a line charge, I am going to take it in the form of a line, and you will find and you will see कि हमारी जो charges है कुछ इस तरह से distributed nature में available है, कुछ इस तरह से. And whenever you talk of a surface, right? Surface का form, suppose you have a plane, right? Something like this, and you have a charge over here in this fashion scattered around all around the surface of the body. So this will come under the surface charge. And this is a volume, right? You take any structure, cylindrical structure, and throughout this is the curved surface of the body. You have this the top part of it. You can have it in the bottom part also. So these are all what scattered throughout the volume of the क्या कहते हैं वो आपका conductor, you say. Okay, conductor तो नहीं बोलेंगे, throughout the volume of the whatever structure, shape and size you have taken. Right, might be cube, might be cylinder, might be sphere. Right, throughout the volume it is being distributed. Okay, and therefore we will come across 3 basic nature of charges, and these 3 are the basic natures of charges. और ये charges को हम actually कैसे define करेंगे. Right, इस काम को करने के लिए मैं थोड़ा सा आपको बता दूं कि देखिए ऐसा है कि हमारे पास एक चीज़ है जो हमने लास्ट क्लास पढ़ा था, that is force of attraction or repulsion. Right, force of attraction or repulsion. Let's put it over here. So it is 1 upon 4 pi epsilon q1 q2 divided by r square. So this is the form. This is the form we had, right? From the Coulomb's law we had this form. और ये जो form है इसी form को अब हम implement करेंगे. लेकिन problem ये है कि you might have this q1 or q2. You might have a point charge over here which is q1. But where is that q2? ये q2 तो अब distributed है in the form of a line. So how will you consider that q2? वो चीज़ अभी आपको देखनी पड़ेगी कि how will you consider this surface charge and how will you consider this as volume charge. इसलिए हम क्या करते हैं, हम इनको नाम देते हैं, राइट? किस तरह का नाम देते हैं कि एक्चुअली हमारे पास कितनी चार्जेस हैं, एक्चुअली हमारे पास कितनी चार्जेस हैं. और इस चीज़ को देखते हुए इफ यू सी ओवर हियर वी आर गोइंग टू से कितनी चार्ज है, राइट? होल्ड ऑन. सो कितनी चार्ज है पर यूनिट लेंथ. So here we are going to say कितनी चार्ज है पर यूनिट एरिया. You can see use the surface area also, okay? Or the last one is कि कितनी चार्ज है. So if this color is not clear, थोड़ा कलर चेंज कर लेते हैं. This is charge per unit volume. So look at the difference between these three. अच्छी तरह से इनके बीच का डिफरेंस देखिए आप. ये तीन डिफरेंस एग्जिस्ट करती हैं. So this is my rho, this is what is sigma, and this is my lambda. So ये तीन representation चलती है. मतलब various books follow various representation, right? You can take any representation, but if you go with the standard Indian authors, right, they prefer this one, okay? So once you talk of a charge per unit length, immediately the unit becomes, it is coulomb per meter. So हमेशा न्यूमेरिकल में ना इस यूनिट के ऊपर ध्यान दीजिएगा और यूनिट देखिएगा क्या है, और उस यूनिट को देख के यू कैन डिसाइड व्हाट इज दिस पैरामीटर. इफ यू लुक एट दिस यू विल फाइंड कूलम per meter. In this case you will have coulomb per meter square. Now look at the unit, it's area. So area is meter square, and if you come over here it is coulomb per meter cube, right? It's volume cube, right? Coulomb per meter cube. Now have a look. So इस तरह से हमारे पास तीन जो है चार्जेस के बारे में आ जाती हैं कि तीन तरह के चार्जेस हाउ डू एग्जिस्ट, हाउ डू दे एक्चुअली एग्जिस्ट एंड व्हाट इज देयर यूनिट. ओके, तो ये एक इन छोटा सा बात है कि चार्जेस एक्चुअली रहते क्या हैं, कैसे हैं, और इनका नाम कैसे दिया जाता है. हाउ डू यू गिव नेम, असाइन नेम्स टू इट, राइट. और अगर मैं इस चीज़ को थोड़ी सी इलैबोरेट करके देखूँ तो मैं तुम्हें एक चीज़ बताना चाहता हूँ आप सबको कि देखिए ऐसा है कि हमारी जो लेंथ की क्राइटेरिया है, राइट, that is charge per unit length, charge per unit area, these two will give rise to a vector quantity, but your volume is a scalar quantity. But how this is being done, let us see that. Okay, now suppose I say Q is nothing but charge per unit length, L. So definitely I can say now Q is equal to rho into L, right? That is just a simple cross multiplication. And from here, if you take an elementary length, you will get an elementary charge, right? Elementary charge. And if once you integrate both the side, you will come across this. And here is my Q. In this case, is your for a line charge. Therefore, मैं अपनी Coulomb's law में ये चीज़ implement कर सकता हूँ. If you look at the Coulomb's law, now I can write it now as 1/4 pi epsilon Q1 के जगह पे मैं अब यहाँ पे integration of rho dl with your Q2 divided by r square मैं लिख सकता हूँ. और अगर फील्ड है तो फील्ड in case of an electric field you will have only one charge, so you will have only this part, not this one. But if you talk of a force, you will have it in this way. Clear? तो इस तरह से मेरे पास rho dl का कंसेप्ट आ जाता है यहाँ पे, जैसे आप देख रहे हैं. Exactly in the same way, what happens in case of an area? So I will write sigma to be as, here I am going to put it as charge per unit area. So sometimes you write A, sometimes you write S, whatever you want you can put it. So Q is equal to sigma into A, and therefore let us take an elementary area. If you consider that elementary area, that is dA, and you can write integrating both the side. I will say this as integration of sigma into dA. So this will be the expression. Replace Q with this integration form. Replace Q with this integration form and you will get your result, right, in the form of a क्या कहते हैं वो चार्ज आपकी आ जाएगी. तो इंटीग्रेट करके उसके बाद ही रिजल्ट आती है whenever there is a distribution of charges, right? This is called distribution of charges. Then another thing, we can have a volume. Now what about the volume? Now if you look at the volume part, right, if you look at the volume part, so this is this and this is lambda. So you can say this as lambda. Lambda is equal to charge per unit volume, right? Charge per unit volume, and that is equal to V. So volume is the shape of the body. Might be cylinder, might be sphere, right? Anything. All right, and therefore Q is equal to lambda into V, and therefore dQ is equal to lambda into dV. इस तरह से Q can be written as integration of lambda dV. So look at this. So this is the charge, which is integration of lambda dV. So I've got 1, 2, 3, right? कुछ इस तरह से मेरे पास चार्ज की एक्सप्रेशन आती है. और यहाँ पे केवल if you talk of a point